2 source transformations, and a Thevenin Equivalent Circuit. That's coming up right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. What we're going to have to do is find the current for, if you want to do a Thevenin equivalent circuit, you have to do what's called short circuit current at the output. So we short circuit this, and in order to do that in LT Spice, it won't allow you to just attach a wire here or zero resistance. You can put a zero resistance. You won't be able to get the current here unless you put a resistor here, so it won't read it. But it also won't allow you to put a 0 ohm resistance here. So what we do is we look at the current at R0, and we want to know what that is, and that's 0.100. Now, how do we calculate that? And the way that we calculate is we have to know what the current is coming out through VB. So when you have a short circuit current, then you have a short circuit right here. The only currents coming down through here are this one and this one. So this is going to be at this point. Once everything is short circuited, we have a new equation we have to solve. So what we're going to do is Thevenin. We're going to do KVL or KCL one more time, but we can only do it at this point. And what we have is, again, we have a VA minus V2 divided by R123 plus, let's see, the next one is just going to be C times VA over R4, which is this current right here, whatever's going out, right? So we just measured VA minus V2, VA minus this, or through here. And the next one will be here, which is going to be plus, well, it's actually going to be VA minus VB. But VB in this case is equal to 0 divided by R5. So now that simplifies this equation. Oh, we've got one more here. Plus VA over R4. And that's all equal to 0. So that makes this very simple. We're going to solve for VA. And when we plug all this in, we just get VA when it's short circuited is equal to 0.861 volts. Now that matches what we have right here, 0.861, when we do it through Spice. Alright, so now we can use this and determine the short circuit current, ISC, which was equal to these two currents. Basically ISC is this right here, ISC, because short circuit because we have a 0 ohm resistor, or pretty close to 0 ohm resistor right here, and so that is just going to be VA minus 0 divided by R5 plus C times VA divided by R4, which is that current right here. So we've got these two currents, and then we just calculate those, and that is ISC comes out. Once you plug the numbers in, you get ISC is equal to, well, let's go ahead and put these numbers in, 0.861 volts divided by 30 ohms plus 25 times 0.861 volts divided by 300 ohms, and is that 300 or 500? I think that's supposed to be, no, that's 300. R4 is 300. That's correct. Okay. So that's right. Alright, and that gives us ISC. When you calculate that out, ISC is equal to 0.10045 amps, or about 100 milliamps. Okay, so the last little bit is to determine our Thevenin equivalent, and here is our Thevenin equivalent circuit. The way that we get our Thevenin is equal to V Thevenin over ISC, which is the short circuit current, and that is equal to, we've already determined V Thevenin is equal to 30.575, and then ISC is equal to 0.10046, and that comes out to 304.354 ohms. So now we have the R Thevenin, that's RTH, and we have the V Thevenin. We can write the, we can show the Thevenin equivalent circuit, and here it is. And that is our solution right there. Here's our VTH. Here's our, it's 30.575 volts. Here's our RTH, is 304.354. And that's our solution. Okay, and that solves this problem.
Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.